better to move back. Let's get this. I'll start here. I presume I'm live. Oh, I'll wait till I get somebody mentioning I'm live here, and then I'll start just kind of bringing people up to date on the small stuff.
Yeah. It's only 5:30.
Yeah, there's 4 people watching, supposedly. Anyone out there seeing me right now? Okay. Christy says we're live.
Okay.
Hi, Christy. I don't recognize your name. Are you related to Alan or somebody else? Well, thank you, Andy and Amy. Let me write everyone down here. Andy and Amy. Okay, Andy and Amy, you're in the drawing. Mr. Lodak, you're in the drawing. Earl Jones, you're in the drawing. And what the drawing is, could you get the book off that table there? Last week, Eve and I went over to Butte, and we were primarily interested in getting information, publications from the Bureau of Mines. And thank you, Christy. And so that was the big plan. And okay, Forrest, you're in. And that's at the University of Montana Tech in Butte there. And you're in the drawing, Forrest. And then one of our viewers, Zioxio, is a student there. So we met him, and then we went to see the Ringing Rocks on the way back. Now, interestingly enough, while we were getting the publications, a gentleman walked in and asked me if I could get him some information or whatever. I'm like, no, I'm sorry. You're going to have to ask the lady over there. And started talking with him. And it turns out that this gentleman is very, very knowledgeable. As a matter of fact, he's the lead author of this book. And Dan Holman, okay? Dan, you're in the drawing now?
How many numbers so far, Bear?
7. And so we chatted and this and that. And he offered his assistance if I needed a little bit hither and thither or whatever. And he apparently knows someone who's even better than him at gravity separations. So that was very, very good. But while I was sitting there talking with him, Eva suggested that perhaps it would be an idea to have him sign his book. So I bought 2 copies, and this one is an autographed copy of the book, which Miner Jim here is very, very complimentary on. He says it's a very, very knowledge-packed book. Applied Gold Placer Exploration and Evaluation Techniques. So that's the giveaway tonight. And what we're going to do is everyone calls in. Now, everyone has to put a comment on there. Terry Curie, you're in the...
So he's number 8?
Yeah. And so what we're doing is everyone makes a comment. Every new name, I'll let you know that I saw you. And write down your name on a list with a bunch of numbers. And then at 9 o'clock, we're going to draw numbers. And whoever wins gets the book. James Wilson. James, you're in the drawing. So, hello, Andy and Amy. And so that's what the drawing is going to be this tonight. And it's going to be interesting. I haven't tried anything like that. Hello, Winging It, Tracy. You're in the drawing now. If anyone hasn't commented and you're watching and you want to be in the drawing, just make a comment and then listen for me to confirm that you got it. So we're currently working on trying to get perhaps a little bit of a collaborative effort here. Joseph Bieberly, you're in. And this Montana BOR is so challenging that rather than spending a lot of time and effort trying to figure it out myself, if we can get the people at Montana Tech to jump into it all, then, hey, Chris, you're in the drawing. They have the equipment, the expertise, etc. Things like examining the rock to determine exactly where the gold is. And that's a fairly challenging task to use either a microscope or electron microprobe or things like that to actually locate individual gold particles. You don't want to be drawn? Okay, Chris, you're eliminated. Now, you want to be in the drawing or not? What we're doing is we're giving away an autographed copy of this book. Yeah, we're early because I'm trying to get some stuff done, Stephen B. And
so Chris is a no or a yes?
I don't know. I'll find out. So they have the resources to do those kinds of tests. They have flotation chemicals. They have flotation test equipment. You know, if people have been watching the videos from last week, you'd see they've got what it takes to figure out the answers to the questions that I have. So okay. So anyhow, Chris is out. He can get a hold of a copy another time if he needs it. So anyhow, talked to the head. Well, I emailed the head of the metallurgy department. He's going to check with the instructors and see basically is there a graduate student that needs a project or something like that. So we'll see. I mean, it's essentially the general procedure that you'd use on any ore, but this ore is not just any ore. So it's going to be a little more challenging. And Jim here is here today, and he's brought some audio visual aids, which I'll probably have to hold up in the air or something. We'll have to see how this works. He's going to try and work on basically once you've determined an area has gold in it, and it looks like it might be useful, profitable ore body. How do you evaluate it, and what do you look at, and things like that? So what he's going to go over today is pretty much what's in this book. How coincidental, huh? Man, I just don't believe how things just work out that way. It's amazing. And still haven't gotten a job, but we're starting to work on for the season to so that when the weather allows us to get in the field, we're not having to do other stuff, rather than work in the field. And I'm glad we're not in the field right now, because when I got up this morning and looked out the door on the porch, the thermometer said 10 degrees. below zero. And there's, I don't know, 10 to 12 inches of snow that's come down the last day or two. It's so cold that there's no melting, no ice, nothing like that. It's just basically powder snow. And the truck, it was funny. The Bendix on the truck didn't want to actuate this morning. It didn't grab the flywheel instantly. And but the truck started, and it warmed up okay, and we were driving it around. The new tires I put on the truck are doing real good. The traction is great.
So, till it gets too packed and icy, but
Yeah.
hopefully this will only be a week-long event here.
Yeah, I've got it in four-wheel drive.
That helps.
Not only does it help accelerating stuff, but I did some testing the other day. Nobody around me, slam on the brakes, two-wheel, four-wheel. And by having it in four-wheel drive, the braking effort is equal on all four wheels. With it in two-wheel drive,
The front end wants
the
to
front
slide.
wants to slide.
Yep.
Exactly.
Yeah.
And I also found out that in very, very poor lighting conditions, as in fairly early in the morning, with a heavy overcast and a little bit of snow and this and that and the other, over there by Power 1000 and what do you call it? Harbor Freight,
Yeah.
parking lot in there. Well, they've got the usual selection of curbs everywhere with no real reason for it.
You don't know where they're at.
And the snow had kind of covered those things up. And I found out that if I'm driving in fresh snow like that, it's best to have a four-wheel drive pickup.
Yeah,
Because if I'd been driving a Kia, it would have gotten messed up. Just driving along, what the hell?
Wonder what that was.
I knew what it was. It was curved, but went over it just fine. So anyhow, weather's cold, snowy. Spent the weekend fabricating, and you'll see what I've done later once it's done and actually being used. But so it's been a nice weekend. I've put in, 12, 16 hours fabricating. I'm feeling great.
Good.
I love doing
Good.
stuff like that,
Yeah, it occupies your mind a little too. You can think and do.
Well, okay. William Harrison. William Hanson, sorry.
So Williams in?
William Hanson is. You're not writing down names, just numbers.
Yeah, I know.
Okay. Yeah, I
I'm
replaced.
still trying to find out whether Chris is in or out.
He's out. Lincoln. Okay, Lincoln Stovall. Okay, Lincoln, what's going on? We're giving away a book tonight. So when I was at Butte, the author of this book happened to be there, and I got an autographed copy of it. It's supposed to be a very good book on Placer evaluation, which is the subject for tonight too, coincidentally enough. So at 9 o'clock, I'm going to be drawing. Everybody that puts a comment on there, I've been writing down your names. We'll draw a number and we'll see who gets it. Oh dear, Chris, that's undesirable. Nova Scotia, 16 inches of snow and 60-mile-an-hour winds for the next 18 hours.
Yeah.
Wow. Hey, Zioxio, how's it going? You're in the drawing for that book now. You don't need to worry about it. Thank you for your tour and your courtesy over there. Really appreciate it. James Wilson, 40 degrees C in New South Wales, huh? Wow. James Wilson. Okay, you're in there too. And if anyone hears me call their name twice, put in a comment and say, hey, you did me twice. So, and so I say, I'm just making a list here, putting everyone's name on it, and Eva will, she's making a bunch of minus 30-degree weather at the end of the week. It's supposed to be getting colder.
Yeah,
No,
Thursday and Friday look brutal.
I don't want to start the truck.
No.
It's got the coolant in it that should handle it.
Don't open the door. Stay in.
And Robert MacGyver, you're in the.
Okay, just every once in a while, let me know what number you're on.
I'm up to 17 in the drawing.
Okay.
Yeah, it's not bad. I'm doing pretty good. Keep it running the whole week. Yeah, Chris. Yeah, sure. I got a better idea. Have plenty of food. Don't go anywhere. How's that?
Don't worry about it.
Hell,
Yeah, it looks like we're gonna get a several-day cold snap.
if you
Yeah,
at 30 below,
Friday.
maybe running over curbs will break your tires.
No, if 50 below might.
Terry, it would depend on the exact conditions as to which is easier to keep cool or keep warm. However, cold will kill you faster than heat. If you were like naked in 50 below, you would die faster than naked in 150 degrees. You know? Well, we'll have to see, Zioxio. I got a hold of the metallurgy person there, and so he's looking around to see if somebody wants to do that. And he said he'd get back with me next week. So if that comes through, then I'll of course be trying to do everything I can to video the whole thing, and we'll just see what happens there. So that's pretty much, I think, all that's happened this week. We did that trip, and I say I got going on the mining stuff. And thank you everybody for the suggestions on the CAD program. Whoever it was who suggested, what was it, QCAD?
QCAD.
QCAD. Yep, it works pretty good. The format and everything is very similar to generic CAD, so it's pretty easy for me to make the transition, and it is Windows compatible.
Bear,
Yeah.
do not forget, tomorrow is a historic day.
Tomorrow's my birthday. I turn
Oh.
65. I'm an official geezer. I felt like a geezer for years. I don't see what the big deal is. James, I've been in Yuma, Arizona, and routinely gets up to 110 to 120 degrees, which I think 110 is about 40 degrees centigrade, but I'm not sure. Thank you, Mr. Lodak. And thank you, Christy. And same to you there, Chris. But yeah, it's pretty bad. The worst heat I ever had to work in was
110 is 43 degrees Celsius.
Okay, so yeah, see, 110. We're probably looking at only 106 or something. Hell, that's balmy. That's no big deal. And the thing that we were lining a pond with black plastic in 110 degrees, and the sun, it was summertime, so the sun was at about 1.2 kilowatts per square meter. And yeah, we were in bad shape by 10 o'clock in the morning. We had to just stabilize everything and just bail. And yeah, it was ugly. We had 6 people to do a 3-man job, rotating 1 a minute. Your working life was about 3 minutes. It was just ridiculous. It's literally like working in an oven.
You're being cooked.
Yep. Yeah, it was just bizarre.
Well, remember in the log cabin in the summer when the AC wasn't working?
Yeah, it's nothing like that. I mean, it was
It's not 130.
yeah, I say not that big. Okay, Donald, I don't think you're in the thing yet. Nope.
So he's number 18.
Yeah. Donald Covington. We're going to have a drawing tonight, Donald, at 9:00. So
Since it's Bear's birthday tomorrow, he's giving away a present to other people.
95 degrees, 100% humidity, full PPE. Yeah. Yeah, that'll get you pretty bad,
Oh, forget that.
you know.
I
And
grew up in Boston.
that same summer where we were lining that pond, eventually it was filled with cyanide solution, but to get started, we had to fill it about half full of water before we started mixing stuff. So for the week or two it took us to get it half full of water, it's a pretty big pond. End of shift, man. Everyone's taking off everything but their pants and just boom into the pond. Yeah. And oops, Javier Cabrera. Okay, Javier, I don't know if you noticed, we're going to have a drawing tonight. And so I'm writing down everyone's name and then we'll draw at 9:00. Okay, Jeremy, gotcha. And Jeremy P. Okay. So, good Lord. Swing. They can hear that little one. So let's see.
If they're bothered by Judy Garland, they have a problem.
So let's see. Anything else this week? I don't think anything of any substance. And how's your week been? Boring?
No, I was working on some hard rock stuff on my copper project out here. So I had some paperwork to do, and I've been working with Forest Service on the permits. We're trying to finalize the permit for doing some trench cuts up there and restabilizing some portals.
Mm-hmm.
So that's always fun to deal with those people. So,
Forest Service?
yeah.
I don't think fun is the usual word that people
I'm trying
use
to
for
be,
Forest Service. I'm getting this. Yeah.
Yeah, we may have to adjust lighting
Let's
here
see.
when you get that far.
Hi, everybody.
Let me see. Ray Solomon. Hello, Ray. And you're in the drawing now. At 9:00, which is 3 hours from now, I'm going to draw, and whoever wins gets an autographed copy of this book. Forrest says hi, Eva.
Hi, Forrest. Hi, everybody.
And so you're just trying to get some of the preliminary stuff on that
Anything
one.
I can do before the weather gets nice, but we don't know when that might be. So,
Yeah.
you know, you keep working on it, and it's, you know, one step, one more step.
Yep. Well, that's what, I'm trying to do here.
Yep.
So if we can get Montana Tech involved,
I think
then that should work.
that could be interesting.
Yeah. Christy Robertson says hi, Eva.
Hi.
Chris Georgie says hi, Eva.
Hi.
And Lincoln says service who? I'm not sure what that meant.
Forest Service.
Forest.
Oh, yeah, Forest Service. Exactly. Yep.
Permitting.
Yeah, USFS.
James Wilson. Do I have a James
Yes,
Wilson?
Yes, you did put him on.
Yep, he's there. Okay. He says he's got some very nice silver, only 2 hours from Sydney. Is mining silver at today's prices worthwhile? It all depends on what the grade is.
And what other.
But the silver
there's
prices are
yeah.
doing good right now.
And if there possibly is a different mineral or element that can be taken out of the ore, also can change the value of the ore.
Yep. Hey, Secret Squirrel, you're in the drawing. 9:00. If you can get me a polished section of one, I could take a peek under the microscope. I'll have to talk to the boss and see if I got any larger rocks. I should be able to find someone. Okay, Truth Seeker, you're in the drawing. Joseph Bieberly. No, Eva's not working calculus.
No, Eva's investigating silver prices and watching Judy Garland videos.
Mike Zumi, happy birthday. Thank you. He's from Belfast, 35C with 40-mile-an-hour winds. Isn't that a little warm for right now?
Yeah, minus 35. See, I can.
Or maybe it's not Ireland. Maybe it's Belfast, Australia. You're going to have to take over the talk for a minute here while I get caught up here. I got a bunch of people.
Well, I'll say hi to everybody out there, and we're going to continue tonight kind of from where we left off on last Sundays. I'm going to try to kind of lead into, okay, we found a piece of property now. How do we start the evaluation process and take us into digging a test hole? And why it's important to have your field notebook and make notes for every hole you dig that you can refer back to understand where in this mineral system that you are.
Forrest Anderson had some gravel hauled in for his driveway. It's got gold in it.
That can happen.
Truth Seeker, okay. Let's see. Okay, I think I've got everyone. Northern Ireland. Belfast is at 35C? Man, it's wintertime. Did I
More motion current.
misread something there?
Maybe minus 35.
Minus 35? That's real cold, too.
Well, that'd be winter.
Okay. Okay, Chris is looking for a microscope, a trinocular petrographic scope with 1,000 power, polarizing setup, and 0 strain optics. Sounds
like what I
serious.
want, but yeah, it sounds like what I want, but
Has he checked American Science and Surplus to see what they have?
I don't think American Science and Surplus is going to have something of that quality.
They get all kinds of strange stuff over there, but you have to check frequently.
Yeah, well, say this is about a $10,000 scope, probably.
Oh,
Yeah.
that's different.
scientific.
Yeah, this is serious stuff.
Jake says happy birthday.
Yeah, he's on here too.
Have you got him on the list yet?
Yep, he's on the list. Oh,
What
yeah.
number are we on?
Now, let's see. We're on 28 so far. Kevin All, Jay Corby, Jeff Bybee, and Mike Zumi. Joseph Bieberly, you're all on the list for the drawing.
Now, at this rate, I better make another slip.
Thank you, Jake. Yeah, Chris is looking for Unimat, Leica, Olympus, Nikon, the usual suspects. That's what I'm saying. Not the sort of thing that American Science and Surplus usually deals
You can
with.
check the government surplus websites.
I think Chris knows how to scrounge the internet pretty good, but there's used lab equipment. I looked up and they've got a lot of interesting stuff. Okay, is it 6? It's almost 6
It's
o'clock.
almost 6, so
So you're about ready to rock on here. Yeah, serious subject matter. Mm-hmm.
yeah.
Still haven't figured out. I think we're going to need some new computer hardware to do the picture-in-a-picture. It just looks like snow. You can't see temperature. So I'm gonna, just don't worry about it.
Well, I'm just going to play with it a little bit. Just then, if we turn the camera, we'll see if We don't want to glare in the camera either. Yeah, there.
Let's see.
I can
There you go. That
move
seems to
this
be getting.
way just a little bit.
There you go.
Okay. All right. We're going to kind of start here, and we'll kind of go over just for a moment what we did last Sunday night, which was, looking for history, looking at maps, picking an area to go hunt, whether you're metal detecting or placer mining. And then at this point, let's just say we found a valley that looks interesting. There's some open ground. It looks like maybe that, there was some placer mining done, and we'll try to take it kind of from that point. I tried to bring some visual aids here, and we'll work.
This might get interesting.
Yeah, we'll work along. Let's see.
Don't worry.
Is that pretty good? Well, I know.
Yeah,
this
it's
is a
reversed
different
in
picture.
our vision, but not
Right.
in theirs. Yeah.
We're looking at a drainage here that, shows some rock piles within it here that was hand worked at one point. We know that channel was kind of worked. We don't know how deep at this point. We've got some interesting bedrock showing down in this area, some, push out of granite, whatever. We see this bend in here and kind of a valley or a bench. Well, that's very interesting from this standpoint, because that would be good areas to start a test hole. So I got to grab my other pen here. I'm going to draw on here just a little bit. Because what we're looking for in a placer is an ancient channel that, when you're looking at the surface material, what you're seeing today wasn't something that was there earlier. Now, I drew in with orange here. That's probably close to where the ancient channel is. It could be somewhere between the two, but the ancient channel in here, just because of this lower bedrock here, the bedrock was the control. The water couldn't break through that, so it had to go off of it. So your edges of this drainage are your controls vertically, up and down the drainage. And then anytime you can find controls that would affect the drainage, there's a good chance that down in here you've got some pretty heavy gold, because this would have been a fairly substantial channel, more than likely, leading back into what you see as the existing creek today. So it's to open your mind, is why I'm doing this, is to look at the drainage, and like I was saying last Sunday, walk both sides of a drainage and look at what are the possibilities, and where would the water have come, and where would it have moved to where you currently see that drainage or that creek. Okay, then if there's questions, go ahead if there is anything
Not
there,
yet.
Keith. Okay. Hopefully you can all kind of see that and make that out. And we'll go to a cross section of the drainage. A cross section of the drainage would look something like this.
Just a second. The current was flowing on that last one from top to bottom, right?
Correct. Yes.
Top to bottom, Lincoln.
Yeah. Down drainage. Well, if you took a cross section of this drainage, you'd be looking at this. I kind of put orange in here as a possibilities of gold. And you've got your rock piles that were old workings along the current drainage, which is the blue here. This ancient channel could be very, very rich, and over time, this creek slowly moved to where you see it today. So when you're looking at a drainage or an area that, had potential gold in it and old workings with the rock piles, you want to pay attention to what other potential still exists. Because in the old days, most of the time the miners were limited to water, so they had to use the water. And that's why they only mined where they had water that was easy to access. Occasionally they brought ditches around the top of a ridge from another drainage and tried to get up higher into this side of the drainage so they could mine that.
Up a little higher.
But
Yeah.
if the bedrock falls over in here anywhere, they couldn't drain their tailings to get they had to be in a position to get the tailings to run away from their sluice boxes and how they were working it. So it leaves a lot of potential, even in areas that look like they were mined fairly consistently and fairly heavily. The possibility that there's still gold there, and really good gold, does truly exist.
No.
So now I'm gonna go to the next step here, is we're gonna dig a test hole, and I'm gonna kind of walk through why you want to document your digging and what that is going to tell you about this placer that you're looking at.
Chris Georgie brought up a point. He says over where he's at in California, ancient channels can be way up on the hill, but they can also be covered with lava.
Yeah.
So you can have placer that's capped with lava.
Right. Yeah. When you get into the blue channel in California and that on top. Yeah, that was ancient rivers that run literally opposite of the way you see the water flowing now. The drainages that are there now cross-cut. That's a whole another level of placer. Actually, that one strip in California. Because of that blue channel where you had a river that actually ran north and south at one point, anciently, and then the mountains raised up, and now you've got drainages that run east and west off of that peak, and that blue channel is actually the top that fed all of those drainages for, I don't know, 150 miles or 200 miles out there. That is an interesting area, but basically I'm trying to keep it basic. Starting at a point, that you do your history, you find a location to go and camp and hunt and start looking for gold. And what you want to be aware and use your imagination a little bit in what happened in this drainage. Where would the ancient water have been? It could be a high bench. I've been on drainages where the high bench is 300 feet above the water, but there's a flat bench up there. And what happened is that was the original creek, the original drainage that laid gold down, and then it slowly come down to another bench and slowly down to a bench, 300 feet away to where you see the water today. Well, when they mined through with the water in that water course, they didn't get that much gold. And that's why they quit the drainage, because there's not enough gold here. Well, they were never looking up on that side hill for that bench that exists. They weren't looking at it from a historical perspective of, if that was the original drainage way up there, that's where the gold, the old gold, the original gold that was laid down in most of these drainages was the first event. Some of these drainages, you'll have a second or an overlay, and I'll get into that shortly when we get a little further along. But you could have multiple events in a drainage that would have been, 200-year floods or 500-year floods, or some kind of an event that maybe broke some more gold loose farther up in the drainage and placed it over the top as an imprint farther down the drainage. So yeah, that's why you do a test hole and you try to do it correctly, because you can identify, was there 2 events, was there 3 events, or is all the gold somewhere close to bedrock on just the original working, the way the water worked it down in the natural sluice box of the drainage. So we'll go to a stratigraphic, a vertical stratigraphic of a test hole. This is going to get a little more complex.
Let's see.
We may have to move back. Yeah, we may have to move back a little bit.
I may have to hold it or something.
We'll see if that'll work a little bit for us.
Nice artwork.
Yeah, well, kind of, Basically, we've got a hole 2 feet wide, which would be like an excavator bucket or a backhoe tractor bucket. And we're going to do a trench 4 feet or so, because you need to be able to get depth. So occasionally you have to, lengthen your cut. Or if you dug this as a shaft, I think I can do it right there. Maybe. Here. Nope. I got some. That might work. That might get me too high, though.
No, that's okay. I can.
Camera.
Yeah, I can tilt the camera.
Here we go.
Is that readable to anybody?
I think it should be. I think I could read it if it wasn't backwards.
Well, yeah, from here it's kind of hard, but
Yeah.
So we start to dig. You want to test your soils. Usually the virgin or organic material here on top isn't really going to show signs of much. You want to test each level as you dig, and you want to measure those levels so that as you note the different rock types and stuff, as you can see, we got $1.20 in gold here on this level above this clay. Well, that $1.20 a yard isn't going to make you any money when it costs you $8 a yard to dig it and wash it. So that's kind of a non-event. But as you go down your layers, you can tell that you've got an overprint event here versus as you get closer to bedrock and into your bigger boulders, your gravels and your boulders, and then down into your actual bedrock. And I kind of got this section I put together as one area here. But there's things you could do here that rechecking this could eliminate some yardage you're running in your plant. If there really isn't gold here, you could possibly strip to this point, and in your dollar increase versus the yardage you're running through your plant can save you some money as you're processing it. Another issue here is as you're digging, dig all of the bedrock that you can dig. If the bedrock's fractured good enough, that gold literally could be 10 feet into that bedrock section. That could keep going down, down, down and have values that if you're not testing it, you would mine the bedrock or slightly into bedrock and leave behind possibly some of the richest ground that you've ever seen if you're not testing that bedrock as deep as you can penetrate into it. Basically here we've got a total of about 3.2 yards of material total. If we can eliminate areas that don't really hold valuable, economic values, we literally can cut this process down to about 1.77 yards of material that we're actually running through our plant. So we're really minimizing our overburden and our cost issues to try to get the highest values out of our gold-bearing gravels and rock. The only variation to that is as you're cutting, if you're hand digging this hole and doing your measurements, you got to keep in mind that your calculations with numbers are really banked cubic yards, and you will have a swell factor that's loose cubic yards. When you get into these bigger boulders and rocks, you can have a swell factor as high as 50%. So even though you can cut the yardage that you're running through the plant down, when you actually are digging this as a mine or in volume, you'll have some swell within that rock and gravel that your numbers will be slightly different than your original test numbers because of the swell in the rocks and gravel when you put them on a pile. I'm sure a lot of you have dug a hole in the yard and you try to put the dirt back in the hole and you always have a little bit extra dirt. That's the swell that you've taken the compaction out of the material and now it won't all go back in the hole. And that'll when you get to material, if you're excavating out, dump truck loads of material, you need to calculate the swell factor to figure out where you're really at. And that is in that book. The calculation is the same in the gravel industry or anything as far as swell on an excavation. You want to dewater your hole. If you're digging this and you get into the water table here somewhere, if you get into that, you want to keep that hole as dewatered or dig it as fast as you can to get this material out so that you're not chasing gold. Because if you start loosening these rocks up and you're in water, that gold will keep going down, down, down. You'll be chasing it all the way to the bottom and you'll actually purge it into the sides of your trenches. So you do not really want to dig test holes in water. Ideally, drain it,
pump it out, dig as fast as you can, and then pump it out so that you can read the sidewalls of these differences in the, in your hole. And sometimes you may have 3 differences in a hole, and depending on the depth, you may have, 10 differences. And you want to check every one of those differences for gold to determine where your economic value is going to come from within the system. And this is basically what one page of your, I'm going to turn this right here.
If you can.
Yeah, and try there. That's not too bad. A little easier to hold it. If kind of lost my place there, but you want to note this basically should be every note page in your notebook when you're doing this. This is really what you should do with every test hole is literally draw it out, give the measurements, give a slight description of, cobble, gravel, sand, clay, sand, maybe a color. You want to, if you do this, by the time you get to the 10th hole that you're digging, maybe on a test, you'll be able to start to kind of figure out where there's changes in bedrock. If the depth of bedrock in other places are unknown, you can start to predict what you're going to find if you go over there and dig a hole. And that's kind of what you want to do. You're trying to predict, is there enough economic value here to make this worth, mobilizing equipment and turning this into a profitable enterprise.
Okay. One thing here, when you're digging a deep hole, it's obviously going to be a lot more difficult hand digging or whatever, but also you have the potential for a cave in.
That is an issue. And what they did in the old days is they actually would crib with lumber. They would crib this as they dug, and they literally keep adding timbers to the top of their crib. And as they were digging it out, they'd collapse it enough that it would keep falling one timber. And that way all these timbers chase them down the hole, and they just keep adding the timbers to the top.
So basically
and that is a safety concern. If you start to dig here, you get down to 6 feet, and all of a sudden you're in a situation where you've got some water. You definitely want to start to figure out how you can shore this up, whether it's plywood and 2x4s or whatever you want to do to shore it up as you go down so that you don't get in a cave-in situation or have a big rock fall, somewhere up here down on your head while you're trying to, dig that out as you're going down. And if you're working the edge of a placer closer to bedrock, this whole thing might be in 4 feet of ground. It might not be that deep, depending on where your bedrock is. That's you really want to get to bedrock though, so that you can delineate, is there values at bedrock or in bedrock, as well as where else, if we've got an overprint, where we had an overprint in this layer above this clay layer acted like a false bedrock whenever this second event here with this stuff happened. Or if, farther up the drainage, something unplugged and sloughed all this deeper gold back up on top of this clay layer, you want to be able to delineate that and start to read the drainage for the value, because 98% of your value here is in this bottom section. So I've got, 24 inches, 36 and a foot. So we got 6 feet. 98% of our value is right there. This $1.20 a yard isn't going to make you any money. It's cheaper to strip it because your stripping cost is a few dollars. Your wash plant cost is going to be anywhere from $5 to $8 a yard to run it through your wash plant. By the time you dig it, you put it through your wash plant and then figure $1 in reclamation per yard coming back. You definitely want to do your calculations. That's why testing is really, really important to figure out, do we have economic value, at what depth, and then you can start to build a mine plan and go into building a mine plan and that type of things. But at this point, it's really about why are we digging the test hole? What are we learning when we dig the test hole? And we want to note all of that information, the soil mixes, your organics, your sand and gravels, your gravel to cobble and sand, the colors. Because as you get deeper, if you get into an ancient channel, almost in most places, the ancient channel colors that are unoxidized gravels, that they've been starved of oxygen for thousands of years, will be a red iron stained color or a real yellow or a distinct white color, almost like white quartz. You will get into a distinct zone that's completely different in color than the gravels above it that were oxidized. So those are notes that you want in your field notebook here, so that when you get to further holes or come back later on, do not rely on your memory. I don't care, even if you're metal detecting and you find a nugget, if you can GPS that or mark that on your map, you may not come back to that drainage or that position for 5 years, but someday, if you do come back, having that notebook saves you a lot of time and effort, because you may not be able to find that spot again and come back a few years later.
Okay.
So, definitely your notebook is your best friend.
Okay. Now, come on, enter. There's something else. They were coming up with various shoring techniques, and one that I don't know if you're aware of, Zeoxio probably, is something called raised liner. And what it is, it's a series of partial circular corrugated heavy gauge sheet steel that bolts together.
Mm-hmm.
So you can put like 3 of them in a ring,
Right.
and then another 3 in a ring, and like that. And it creates like culvert.
Right.
But it's sectional, so you can, do that. And also, when you take it apart, you don't have a big chunk. You can throw a dozen of these pieces in the back of a pickup truck. They're easily handleable by a single person. And that's why they do that, is so that
we've used, 2x10s and 2x12s
Mm-hmm.
and 4x4s for our corner posts. Jeff Williams did a really good video at one point on starting a shaft. And that's literally what you're doing. A test hole is a shaft. You're going straight down into the ground. And if it gets to the point where you're worried about safety, then that's what you want to do. You want to put a couple of timbers or whatever, I-beams across, and you want to frame from there down and just continue your framing as you go down. And that'll keep it stable. It'll keep it safe, which you definitely want to be safe and be able to come home after doing what you're doing. But you have to get to the point. That's where an excavator or even a mini excavator is really, really handy, because you can dig a 10-foot deep hole and you never have to go in that hole.
Mm-hmm.
You can stand there and look at it. You can drop a tape measure down the side of the hole. And worst case, you can throw a ladder down quick and a paint can. You can mark your differences in your soil changes or your rock changes. You can make your measurements quick, get out of the hole, pull the ladder up and cave the hole, push everything back in. Unless you're going to take samples. If you're going to actually take samples from that reading, then you want to, lay them out accordingly as you dig. If it changes, you start another little pile. So each of those samples is independent.
Well, another thing you could do too for safety, if you're trenching, with a backhoe, basically, once you've got your hole, you could also take just a little video camera or something and lower it down, put your tape measure down, and then just lower it down along the tape measure.
Yep.
And as you're going down the tape measure, you have a video of exactly what it is.
But you definitely you want to do notes, because that one test hole right there tells me a lot about that placer at that point. Now, if you move up move back up the creek again, you may want to do some lines across this drainage that you do multiple test holes, and you may want to check the opposite side of the drainage, but you got to concentrate on one area. Well, this would work out. You could plan out some mine cuts in this
really comfortably. And if you can find that ancient channel around the outside, you not only can you high grade it, even if this is some lower ground in here somewhere, if you do your mine patterns right, maybe you can pick up some really high grade out here somewhere, and you can pick up the high grade around the outside of that bend. You may be able to make multiple cuts there, and all of the excavation and all of the gravels you run, like you're seeing on Gold Rush right now up there, is economic. All of it. So it's thousands or tens of thousands of yards possibly that are economic to the point that you can make money if you mine and reclaim that whole thing out of there. And you always want to try to go back also somewhere in the drainage where the old timers worked and try to determine, did they get to bedrock? Because in a lot of cases, they had to keep the water and the gravels back going downstream. If they didn't get to bedrock, there's a good chance you've got values from one side of this drainage all the way over here to the other. So that there's things that you want to try to learn about the drainage, or that, you know, what the old timers did, what their limitations in that drainage would have been, and then build from there.
Now, you said that see where the old timers went. So how would you determine the soils that have been put in there after they dug it out compared to what hadn't been touched?
Usually your upper rocks could have moss or willow brush growing on them, or something that, you know, eventually kind of started the ground, nature started reclaiming it.
Yeah.
But if you start to get down into rocks that are literally all washed, there's no gravel stuck to those, you know, stuck to those rocks, that's washed rock. And you can usually tell if it's washed rock because there's literally no clay, no sticky in it. And you can go down into the water table that way, and you can actually tell that these are all washed rocks. Yeah,
So
they're blue and gray because they're oxidized, but they're washed because there's no sticky clay. There's nothing attached to the rocks themselves.
So when you're going down and looking for original sediments there, clay is a big clue.
It's a big clue, and the drainage may not have that much clay. I mean, you know, we're in an environment where there was volcanic clay, just because of these episodes that created this gold and the mineralization in these veins and stuff. And granted, by itself, as it degradates, it turns to clay. Once it gets fine enough, granite is clay. So you definitely, clay is an indicator as you're digging through the rocks, that if it's really stuck to the rocks, or the rocks are really dirty, they were probably never washed, even if it was 140 years ago. When you get into unwashed gravels and rocks, it becomes real self-evident, if you're paying attention, that, okay, now that's virgin rocks. And sometimes it's a little on edge. It's like, is it or isn't it? But then you go a little bit deeper and go, oh, nope, that stuff from right there up that's all just been put back in.
Yep. And don't forget, if you got questions anytime,
bring
just go
up
ahead and put them in.
if you've got questions.
Oh, you're doing a good job.
I hope I am. I hope you guys are entertained.
Well, you're doing fine. So you've got a number of test holes, and you're trying to ascertain the thickness of the layers,
Right.
the composition of the layers, the grade of the layers,
and depth to bedrock.
and all the depth of bedrock. And then are you mapping that too?
Exactly. That's really what you're doing, is not only are you writing this, showing this test hole in your book, in your field notebook, or just a lined notebook. This test hole, this is what it looks like. And it can be crude, but you want them depths, and you want to know where bedrock is, because if you go up the drainage, let's just say we go 250 feet or 200 feet up the drainage and we dig another test hole. Well, the one we just dug was, let's just say it was only 6 feet deep. In this case, I pictured it as 11, but let's just say it's 6 feet to bedrock. We go 200 feet up the drainage out where we think we should still be on the channel or something, and suddenly it's 29 feet to bedrock. We've got a control in that drainage that very, very well could have left us a whole big pocket of gold up in that drainage somewhere because of the change in bedrock. that the water had to go up and over to get to that higher bedrock. So we've got controls under there that we can't see. We're looking at a drainage that maybe it's all trees and brush and willow brush and beaver dams. We can't see it. That's why you got to do the test holes, is to try to figure out what were the controls that would have left us some gold somewhere in here. Because if that bedrock shifted one way or the other, it can leave you a pocket like a waterfall if it shifted one way and the water goes off. But if it shifted the other way and the depth to bedrock drops down, and I know a couple places where I personally seen that, and if it did drop off, there's a good chance that was the biggest gold trap. It was just like a riffle in the sluice box, but it's a big riffle. And, over the years, that gold just gets in there and just keeps working down. And that could be just an extreme, extreme pocket. And that's what you want to learn without digging the whole drainage up. You want to learn it by doing test holes. And if you've got 2 test holes that one says, geez, we got $100 a yard right here on bedrock, and you go 50 feet away, you've got a test hole that shows virtually barren and no gold. You want to go back in between those 2 holes and put another hole to try to figure out, okay, where's the delineation of where the gold starts to minimize? Because you don't want to dig ground and move ground with no gold or run that through your plant. You only want to run economic value ground, and you need to know, how am I going to map this out to mine it? You need to know where the gold is. The last site we were on was about a 10-acre placer. We dug 30 holes in there. We spent 3 months just digging holes with an excavator, taking 10-yard samples. In some holes that were deeper, we actually were 27 feet to bedrock in one side of the drainage. We took 10 yards in the upper, we took 10 yards in the lower, and we did our channel sample just like I was showing you, where we did each individual depth, change in rock, sand, gravel, clay. And then we had those samples, we washed them, we calculated the yardages, and then we were able to go back at the end of 3 months and say, okay, we want to start mining way down here on this bottom corner. Our first hole pass that we're going to make is through ground that's running anywhere from about $10 a yard to $26 a yard, so that it all becomes economic in the end.
Okay, we got a little bit here. First of all, Goldstream Mining says he likes trenching for testing.
It's trenching. If you can
Is
trench
he
the
on
whole,
drawing yet there?
if you can trench the whole drainage all the way across it, is the best way to test it. But
Is he in the
in some
drawing?
cases with too much water or certain limitations, if all you can do pothole it for test holes, that's okay. And then take that information, and if there's a deviation between test holes somewhere, either upstream or left or right of this test hole, that the values are completely different, you need to go back and punch a hole somewhere in between and try to delineate where's the value and where does it become uneconomic.
Okay, now a number of people here are bringing up different geophysical techniques.
There is some, and the biggest one would be using either magnetics or ground penetrating radar can get a certain depth, but if you get into a lot of water, you lose it. You can do, I can't think of it now, seismograph.
Yeah.
They can do seismic, and seismic will give you the periphery of the valley drainage, the cross section that we were looking at. And that can tell you a lot. And it can tell you if there's any big changes in bedrock, because if you do seismic on the drainage, you may be able to see where the ancient channel actually is by the seismic, because a channel is not a straight line. It was moved. There was controls under there that varied it. Like if you've ever played in the mud puddle and you take a stick and you start drawing water, down away from it, all of a sudden the water hits a rock and then it goes around the rock 2 ways or to one side. That stream did the exact same thing on a way larger scale.
as far as how it eroded left or right or serpentined, or sometimes even it crossed, it braided. And if it braided, you have multiple channels in there and you're going to have some ground that isn't that valuable. And that's why you do your test holes or trenching. Ideally, trenching is the ultimate, is you trench, go up the drainage trench all the way across the hole, map it, test it, move up again and do it again. It just depends on the size of the environment and what you got to work with. If you're looking at this from a high banker standpoint, you're going to just do a test hole. You're going to dig one hole, and if we got gold, we're going to figure out where the gold is. We're going to, learn everything we can about that hole. And if we come to the point where it's just not sufficient gold or not enough gold or maybe very little gold, then we got to go dig another test hole. And eventually, over a period of time, you will have enough test holes in there that literally, if you were mapping it and putting it in your field notebook, it may be able to tell you that, oh, now I see where the gold is, and I know why that test hole, was no good, or that one way out on the right was no good, is now I've zoned in on it.
Okay. Lincoln asks, can you use the same process in the big bucket dredge tailings, or has it settled in small pockets?
We've went in where there's been dredges that ran, and I'm not saying every drainage, but a lot of the drainages, depending on where they started in elevation in the drainage, they did very, very well down to bedrock. And unless they got into some boulders that were bigger than their dredge buckets, because if they start hitting boulders, they had to retract the dredge up and go over the top of them, which in that case, they missed the best gold because it was below in and below those big 4-foot boulders. In a lot of places, though, I know we were over in Gold Creek at one time and dug some holes. We had one test hole that we went down 90 feet over there. It took almost 4 acres of digging to get down 90 feet because everything from the old dredge kept sliding in on us. And the only way we could do it is just to keep digging and let it slide till it quit sliding. And like I say, it ended up to be a hole that looked like a volcano to get down 90 feet. And believe it or not, the dredge had taken some of the bedrock. There was no gold. So it was a $70,000 test hole that was absolutely worthless.
Now that might be a good area where...
And that's one reason to know the history. My guess would have been that the dredge did get most of it, unless there was some real change in controls that you've seen in the drainage where maybe the bedrock dropped off and the dredge didn't get that deep. Because the dredges had limitations also. The dredges, most of them that ran here in Montana, especially the early small ones, had limitations of 35 or 40 feet, 45 feet. So if the the main channel was deeper than that, the dredge never got there either. In this case, most of what we've been talking about is really for the guy starting out and wants to go out and find some gold. Ideally you're going to find a drainage that doesn't have 6-foot granite boulders or the size of school buses at the bottom. And it's not, even right now with the price of gold, if you've got to excavate 90 feet, 50 feet of overburden to get to paying gravels that are 27 feet deep or something, you got to really do your pencil on that one, because there's a good chance that you could, literally do that digging and you're still not going to make money because of the depth. So you've got to put a pencil to it and figure out where's bedrock, what could I get that maybe the old timers missed within this upper gravels even. And a lot of drainages I can almost walk down and go right over there. They missed some gold. They left a little bench, and then when they got farther up the drainage, they worked in above it. And it's like, well, why didn't they work that? It could have been a water issue. It could have been a seasonal change. It could have been an ownership change, because some of these drainages, the claims were only 100. A guy got 100 feet of claim and from bench to bench. So he only had 100 feet to mine and then out to the 2 edges of the drainage. Well, then the next guy had the next 100 feet. Well, if that was the case, sometimes the guy up above you didn't get his mind before the guy that a mind above him again. So the historical perspective plays a big part of looking at a drainage that already had work. The gold is there. What did they leave? What did they miss? What's the potential that I can find the same thing they were finding? And it's still there. I would say in Montana here, less than 5% of the gold that's here was ever actually found. In some of these drainages, these guys took out millions of dollars. That's $16 gold.
What were the sort of things that would limit where a dredge could mine? Is it, you know, I was up in the Middle Fork of the Boise, and there was dredge spoils there and everything. But what were the limitations so you could take a look and say, oh, well, the dredge couldn't get that, and he couldn't do this or whatever? What would slow him down or stop him?
On one drainage that comes to my mind, what stopped the dredge is it found a control in bedrock that was a cross formation that they literally ran up against the side of a waterfall because they came in farther down the drainage, so they were able to dig deep. They could take off like 40 feet and then take out 40 feet under that because they came in farther down the drainage, so they were able to dig deep. They could take off like 40 feet and then take out 40 feet under that, you know, so they could dredge deep. But what their limitation was is when they got to a certain point in the drainage, the bedrock had shifted like that. They literally hit a wall.
So it was too shallow for them to proceed, huh?
Well, they had talked about moving the dredge to above it and start again, and they never did that.
Mm-hmm.
But they did do drill holes that I was actually able to find the reference to that they actually, you know, basically done water well holes dredging.
Uh-huh.
You know, and there is dredge records, like the Bureau of Mines has dredge records where they went ahead of that dredge a season or two ahead of it, and literally they either dug shafts
Mm-hmm.
or they actually did drill holes to make sure that if we move the dredge the next season, what can we expect to find?
Uh-huh.
Because if the ancient channel did switch somewhere and it's not evident looking up the drainage,
Yeah.
which is the case, sometimes the ancient channel is over in the hillside somewhere.
Yeah.
And if it changed somewhere and they miss it, they're running all that material and not making any money. And that's an expensive operation.
Yeah.
You can't do that very long. You either hope to get back into gold or you have to shut down. You have to quit. Other things that ended it was 1941, the war effort. The U.S. government made gold mining non-essential. They didn't want guys doing it. They wanted the manpower in mining for copper, zinc, iron ore, you know, things that the Army and the U.S. government needed. So they stopped all non-essential gold mining, came to a halt. There was only 2 dredges that I know of that continued through 1941. And the reason they let them continue, one of them was in Alder Gulch down there in Montana here, and one was over here by Hall, north of Phillipsburg. And they let those guys continue because they had actually created a separation system on the dredge that they could collect all the garnet, and they were bagging all the garnet in big gunny sacks and stacking it, shipping all that garnet for abrasive and finish, and you know, finishes for steel or whatever they were all using it for, mainly abrasives. But those dredges World War II, because of that fact that the garnet had a value.
I mistook it, but I don't think so. So these mining companies, I mean, dredges are a big machine. So you don't
Big
just
amount of money.
you don't move them in there without having a lot of information first.
Yep.
But that information would also tend to be archived at like the Bureau of Mines, etc.
Some of it is. Yep. Some of it they had the drill results or the shaft results ahead of the dredge, farther up the drainages, and you can archive some of that information and you'll go find it. But they did it just like I'm talking about here. They did a cribbed shaft and some feet to bedrock, and that was a test hole. That's what it was.
Huh.
Not that they didn't drift down there off.
Okay, apparently we're having trouble with YouTube right now. It's buffering.
Okay.
Let's see.
Maybe give it a minute.
So While we're trying to figure out what's going on. By the way, is the sound buffering also, or just the video? And while I was up in Butte, let me turn the camera over here a little bit, just to give you what you can get at that. This was the most expensive one, applied gold placer exploration and evaluation, $25. Try and get that at a bookstore. Montana Bureau of Mines and Geology, Guide to Staking Mining Claims in Montana.
Yep, that's a good one. If you,
$2.
you're going to stake a claim, that's good information.
You know, you've got, everyone's been asking, how do you stake a mining claim? It's state specific.
It's got both the federal rules and rules.
Okay. Geologic map of Montana Field Notebook. I forget how much this was. This was relatively expensive.
Yeah,
It's all the geologic maps.
Yep. So you can find fault lines or cross faulting in a drainage that a lot of times if you've got fault lines that cross a drainage like at 90 degrees or 45 degrees to
About 35. Let's see, Terry. Okay. The 9 o'clock thing, so that anyone who's not will have a
chance to get in.
And again, I'm going to just won't matter if it gets interrupted. This is on cyanide leaching, the actual chemistry of cyanide leaching. So that's a good use. Oh, somebody, Gold Panner says Super Bowl may be bogging things down.
That might be.
Yeah.
People still watch that nonsense?
Yeah. Now,
a few.
Here's another one. $3. Marketing problems of small business enterprises engaged in lead and zinc mining. $3. You know? Mining codes of Montana. This is a fairly thick one here. And this was 15. Gold placers of Montana.
That's the one I was just showing. That
loads of information.
Lots of information in that book that if you're going to prospect, even if you're going to metal detect.
Practices.
Yes.
And then they also had a CD. Bench to bench using gas-powered auger, usually about 4 feet apart, 36 inches. Check every.
Not bad.
Lena Tracy says it is. For those of you who are not aware, we're going to do a drawing tonight. When I was up in Butte getting all this information, the author of this book just happened to be there getting some information. So we're going to be drawing isn't on it.
And give me a
comment real quick and I'll do it.
35.
35. What do you go to? Lincoln says, where do you go to way of seeing where to dig? Google or looking from high spots in the area? Lincoln, if you go to last week's live stream, he goes into a lot of detail on exactly how he and how he does the initial examination. Restart the broadcast, maybe. I could do that. Let's wait a few minutes and then I can restart it. Everyone, let me know if you want me to try that. So right now we have Vendetta Prospecting, Christy Robertson, Andy and Amy, Mr. Lodak, Earl Jones, Forrest Anderson, Dan Holman, William Earl, Truth Seeker, Joseph Bieberly, Mike Zumi, Kevin Auld, Jay Corby,
Yes, unstable.
Jeff Bybee.
These came up unstable connection on the top.
And Jeff Bybee, Canadian Gold Prospector, Gold Stream Mining, Gold Panner, Nathan Garvins, Jeremy P, Pokerface, and Gold Miner 49er. So those are the ones that I currently have for the drawing. And at 9 o'clock, we'll actually do the drawing. And if the person isn't watching at that time, do we want to just wait for them to see
I
the
would give
video?
them a chance and then give them, let them email you or their address or whatever, if that's the case,
Well,
I guess.
I mean, if they stop watching by 9, should we just leave it on because it'll be on the YouTube,
Yeah, I would.
and then if you do,
That's a good idea.
whoever we draw, just if you have to leave, just go to the replay thing, go to the 9 o'clock time, and look at 9 o'clock should be about 3 hours and 15 minutes or so into the live stream. Next week we'll do another one. Okay.
If you guys got questions, get them in, fire them off if we can help you.
See, did you see how
Yep.
my head just stopped there?
Came up here too. Connection unstable.
Connection unstable, huh? I don't know why. Okay, so let's see. We were talking. Oh, I had a question. You were saying that the big dredges couldn't handle big boulders.
Yep.
So
If they got into, a lot of times the buckets on most of them were like 3 foot.
yeah,
If they got into rocks that were 3 foot or bigger, it would start pounding the dredge so hard that they'd have to
break
lift
the
up
chain
and
or
go, yep,
whatever.
and they'd have to up and go over them. And then that didn't get mined. Well, in a placer situation, the bigger the rocks, the bigger the gold. And usually the more gold, because the rocks act as a big, huge trap. And it's your high energy channel. You always want to find in your placer, ideally, if you can find the high energy channel, which is the bigger rocks, and maybe they're only big in this form of a basketball size, but if in them where you see the outcroppings of big, there's a good chance that the high energy channel is going to contain those same 4 and 5 foot boulders. And that's where you're going to find some serious gold if you can get into that level.
yeah. Well, the question is, how deep would these sort of things be? And could something like, say, radar or seismic or whatever, could they spot that reasonably easily now?
It's mainly no, it isn't. That's
Okay.
Unfortunately, and then depending on magnetite and that, you could have, if you were using a magnetometer to follow magnetite or even the gold, the metal, you could have an area that's hot, but it might not be the actual gold or mineral you're looking for. It might be a high iron concentration or something that's giving you the reflectivity. But it can give you some, areas that target where you want to put a test hole.
Well, see, that's what I was wondering.
Seismic is really the best.
Okay.
But if you don't have 10 acres to do or something, it gets a little expensive to have them come out and do, 1 acre of seismic.
Well, that's what I was wondering.
If you can find bedrock, that tells you a lot. First of all, is it even mineable? If it's 90 feet deep to bedrock, it may not be mineable unless you can dig in low enough somewhere below to come into it at that depth.
Well, I was wondering, for example, if you
That we mined there, the last one, was all drifted with tunnels that they came in farther down so they could drain the gravels and tunneled it. In some areas, they were very, very efficient at the amount of gold that they took off of the bedrock. I mean, some of these areas were solid posts and rocks 100 feet square under the ground that had you not known and found those drifts, you would have never known that they mined this area.
Mm-hmm.
Because they came in from way down up under it, kind of.
Yeah.
But when we found areas along the edges of what they didn't get, and in some cases they always had to drift kind of in a herringbone away from the creek like this, so that these tunnels drained.
Mm-hmm.
Well, if the bedrock fell off even this much,
Uh-huh.
they couldn't get it.
Yeah.
So when we'd hit the floor of the drifts with the excavator, we'd strip down some places. We literally stripped the ground right to the floor of the drift.
Mm-hmm.
Then we mined everything from the floor of the drift down. And in some places it was deep. I mean, it was another 17 feet or something. Some places it was only 2. But that 2 foot of gravel that we took from the floor of that drift down that they couldn't get was richer than can be.
Good.
You know, so it paid to strip it and it paid to mine it. But until you can find bedrock and figure out what they were capable of historically doing, you would have never guessed that.
Mm-hmm.
You'd have said, this is all mined out. It's been mined. Well, that's not the case.
Goldstream, I see modern seismic is wonderful since they started adapting oil field technology. They literally show you a picture of the underground. Now, I was looking at a possibility of doing some geophysical stuff with a magnetometer up here, and it was like $5,000 a day for a 2-man crew. It ain't cheap.
No.
So that's why I was wondering.
No. If you get, there's other reasons they didn't mine it in some cases. A little too much clay. Well, nowadays, actually, some of these wash plants handle a certain amount of ground sluicing in a sluice box. You know, those guys used water as their excavator and shovels and pitchforks to clean their sluice box. And that was the extent of the mining equipment that they had to wash that valley. Nowadays, with equipment, you can be the quality of the equipment to wash it is drastically different. That was one of the reasons, though, that I mentioned last week in last week's show, is don't go out and buy a bunch of equipment because you want to go gold mining. Go out and find gold, figure out the system that you're in the drainage or whatever, where you can get a claim or lease a claim maybe from another landowner. There's all kinds of different ways to do things, but do that first, and then you tailor the equipment to the site that you're on, because I've got 2 bigger wash plants that are completely different of each other. And in some aspects, one works and the other one would never work. So you want to tailor your equipment.
Were those two, were they drifting for mining or to drain the water?
No, they were drifting, mining it. Basically what they would do in a lot of places, they would start down the drainage somewhere where they knew they had an elevation change big enough that they could start, like, let's say, right in the creek, hit bedrock in the creek and do it again. They tunnel underneath everything. That way they never had to worry about the overburden issue. They were going strictly after the gravels that held gold. But depending on where they started, a lot of times, especially with the excavator, if we started digging, 2 feet off of the creek and found the tunnel, the drift, we could mine for 50, 60 feet or more sometimes before they actually hit bedrock and were able to clean it off. So there was, a lot of depth underneath their drift yet that they were never able to take that gold out of there.
Okay.
They couldn't dig a swimming pool under the ground like that. They had to keep the floor of that drift running at like 1 degree every so many feet, so that if they did hit water, it would drain right out between their feet.
Yeah. Dan says, I use a pipe locator to map the magnetic trail, then sample the magnetic trail. Chris says these days you can get a rather sensitive magnetometer for under $1,000. You can walk a line with GPS without too difficult.
That's true.
True Seeker also saying that if you're having buffering problems, try refreshing and see if that helps.
That sometimes does.
Refresh and drop your
speed a little bit.
Well, your what do you call it? Resolution. Yeah. So.
It's really interesting in a lot of these historic drainages that there's a lot of gold that they did not get. It's still there. Even in some tailings, depending on if they had a lack of water and they washed a drainage, there's a good chance that their recoveries were less than 50%. So if you just work the tailings at the bottom of the drainage up into the drainage, less than 50%. So if you just work the tailings at the bottom of the drainage up into the drainage, some of those tailings in today's dollars are rich as can be. And those guys wash that stuff right out.
Okay, now Joseph, you're correct. Techniques, so you can kind of compare them as a recreational prospector. You normally wouldn't use these techniques, but if you found an area while you're recreational prospecting that had a lot of potential, this is what you would do to determine whether or not there was commercial potential there.
Well, there could be weekend potential. You know, if you do it correctly and you figure out where bedrock is and that, I mean, that one test hole could lead you. But now you got to hunt. You got to look at the areas that they didn't work and why they didn't. If you can go over to where they quit washing a slope and dig into that slope right there and start finding gold, they probably quit because of the season was at the end, or there was a reason they stopped right there. That was their cutoff grade, maybe. Well, their cutoff grade, you know, in 1880 would have been a lot different than our cutoff grade now, the value of gold at $1,800. So, you know, their gold was $16 an ounce, and they wanted a lot of ounces as fast as they could get it. So their cutoff grade was, you know, 15 cents a yard or something. And if it was below that or somewhere in that neighborhood at $16 an ounce gold, they just quit mining. Well, 10 more feet up the bank there, that may change again too. So the opportunity to find gold exists. The biggest thing is you want to understand what their limitations in that drainage were. What did they mine? How did they mine it? What would have made it really hard for them to do a good job? And if you can start to figure out those limitations, you can start to see the potential of what they
No matter what scale it's at. But
every drainage, and like here in Montana, a lot of these drainages, they took out millions of dollars worth of gold down some of these, you know, little creeks for 6, 7, 8 miles. And yet nobody ever found the source of the gold. There might be